Welcome students. In this part I am going to discuss the trends in ionization enthalpy in a period and in a group of a periodic table. As in our previous video, I have discussed the variation of atomic radius and ionic radius in a period and in a group. Now it's turn for the variation or the trends of ionization enthalpy along a period and in a group as well. Ionization enthalpy, as we know that the electrons which are present in the atom, they are attracted towards the nucleus because we know that nucleus is positively charged. So the electrons are attracted by the nucleus because electrons have negative charge, and when we have to remove that electron from the atom, so we have to require some energy, or we have to supply some energy to the atom to remove an electron. So the quantitative measurement of the supplied energy to an atom to remove an electron from an atom, that quantitative measurement is known as ionization enthalpy. अगर हमें अपने न्यूक्लियस के साथ जो हमारा एटम में इलेक्ट्रॉन बाउंडेड था, अगर हमें उस इलेक्ट्रॉन को रिमूव करना है तो हमें उसे कुछ एनर्जी सप्लाई करनी होगी, और वो जो क्वांटिटेटिव मेजरमेंट है उस एनर्जी को सप्लाई करने के लिए जो हम एक क्वांटिटेटिव मेजरमेंट लेते हैं, उसी क्वांटिटेटिव मेजरमेंट को बोला जाता है, एनर्जी को बोला जाता है आयनाइजेशन एंथैल्पी और द आयनाइजेशन एनर्जी एज वेल. नाउ व्हाट इज द डेफिनेशन? The energy required to remove an electron from isolated gaseous atom in its ground state is known as ionization enthalpy. So ionization enthalpy is expressed in kilojoule per mole as well. And even ionization enthalpy is also known as ionization potential sometimes, because it is the minimum potential to remove minimum potential difference as well to require to remove the loosely bounded electrons from the isolated gaseous atom. So sometimes the value of ionization enthalpy can also be expressed as electron volt per atom or kilocalorie per mole as well. And since 1 electron volt per atom is equal to 96.49 kilojoule per mole, and that is 1 electron volt per atom is also equal to 23.06 kilocalorie per mole, and also 1 kilocalorie per mole is equal to 4.18 joule per mole as well. Since the energy required is to remove the electrons from an atom, therefore ionization enthalpies are always positive, क्योंकि जो एनर्जी की रिक्वायरमेंट है, इलेक्ट्रॉन को रिमूव करने के लिए एनर्जी रिक्वायर हो रही है, तो हमेशा जितनी भी आयनाइजेशन एंथैल्पीज की वैल्यू होंगी that are always positive in nature. Now, so according to the definition of ionization enthalpy, when we have a gaseous atom X, suppose this X is a gaseous atom, and this X, after removing electron from this X gaseous atom, we can get an ion for the atom, and the ion will be the cation because the electron is removing from it. And after the loss of the electron, the energy required to lose that electron from this atom X, that energy will be known as ionization energy, and here this energy will be known as first ionization energy. This is because the enthalpy change or the energy change when most loosely bound electron is removed from an isolated gaseous atom. इसे हमने first ionization enthalpy बोला है क्योंकि जो loosely bound electron, जो most loosely bound electron होगा उस atom का, उसको remove करने के लिए ये वाली energy की requirement है, तो इसे हम बोलेंगे first ionization enthalpy. Now similarly, if we have to remove electron from this ion, so X positive, which is in gaseous state, when we remove electron from this X positive, so it becomes X2 positive plus removal of 1 electron, and at that time the energy is known as second ionization enthalpy or the second ionization energy as well. Enthalpy change. This is the enthalpy change when second most loosely bound electron is removed. ये वाली जो एंथैल्पी चेंज है जिसे हमने सेकेंड आयनाइजेशन एंथैल्पी बोला, ये वो एंथैल्पी चेंज है जब सेकेंड मोस्ट लूजली बाउंड इलेक्ट्रॉन को हम रिमूव कर रहे हैं, तो दैट एनर्जी विल बी नोन एज सेकेंड आयनाइजेशन एंथैल्पी. और जो मोस्ट लूजली बाउंड इलेक्ट्रॉन है किसी भी एटम में, अगर उसको रिमूव करने के लिए एनर्जी की रिक्वायरमेंट होगी, सो दैट एनर्जी विल बी नोन एज फर्स्ट आयनाइजेशन एंथैल्पी. और आफ्टर द फर्स्ट आयनाइजेशन एंथैल्पी, जो उसके जस्ट बाद वाले इलेक्ट्रॉन को रिमूव करने के लिए एनर्जी का रिक्वायरमेंट है, दैट energy is known as second ionization energy or the enthalpy. And here also the second ionization enthalpy will be higher than the first ionization enthalpy because it is difficult to remove electron from a positively charged ion than from a neutral atom. As initially told here, the first ionization enthalpy is the enthalpy required to रिमूव इलेक्ट्रॉन फ्रॉम द लूजली बाउंड कंडीशन. जब इलेक्ट्रॉन बहुत अपने लूजली बाउंड कंडीशन में है, मोस्ट लूजली बाउंड इलेक्ट्रॉन है, अगर हम उससे इलेक्ट्रॉन को रिमूव करें तो वो एनर्जी है फर्स्ट. तो वहां से लूजली बाउंड अगर इलेक्ट्रॉन पहले ही है, हम उसे कुछ थोड़ी सी एनर्जी प्रोवाइड करेंगे तो इलेक्ट्रॉन इजीली रिमूव हो जाएगा. तो कम एनर्जी की रिक्वायरमेंट हमें वहां पे यूज होगी. बट इफ वी कम टू दिस सेकेंड आयनाइजेशन एंथैल्पी, सेकेंड आयनाइजेशन एंथैल्पी का मीनिंग है कि सेकेंड मोस्ट लूजली बाउंड इलेक्ट्रॉन, मीन्स वो तो बहुत लूजली बाउंड था न्यूक्लियस से वो वाला इलेक्ट्रॉन. अगर हम सेकेंड आयनाइजेशन एंथैल्पी की बात करें तो इसका इंटरेक्शन कुछ न्यूक्लियस की साइड को ज्यादा है इस इलेक्ट्रॉन का. तो इस इलेक्ट्रॉन को रिमूव करने के लिए, टू रिमूव दिस इलेक्ट्रॉन वी रिक्वायर मोर एनर्जी. सो इट मीन्स द वैल्यू ऑफ द आयनाइजेशन एंथैल्पी सेकेंड विल बी हायर एज कंपेयर टू द वैल्यू ऑफ द फर्स्ट आयनाइजेशन एंथैल्पी. So from here we can also conclude it that the smaller the value of ionization enthalpy, the easier is to remove the electron from the atom. जितनी small ionization enthalpy की value होगी, it will be more easier to remove electron from that atom. Let's check the factors affecting on ionization enthalpy. So the first factor is size of the atom. Ionization enthalpy decreases with increase in size of the atom. It means ionization enthalpy is inversely proportional to the size of the atom. When the size of the atom gets increases, the ionization enthalpy will get decreases. As in our previous video, we have already discussed the size of the atoms in atomic radius, and in case of increase in atomic size, the ionization enthalpy will get decreases. And the reason behind this is, as the size of the atom increases, it means the outermost electrons are less tightly held by the nucleus, and it becomes easier to remove electron, and therefore ionization enthalpy decreases with increase in atomic size. As we know that, as we are talking about the shell, and as the shell number increases, means size of the atom increases. Suppose this is the atom which is having the 2 shells and the 3 shells. As we compare these two atoms, now what will happen, the size of the atom gets increases because of the increase in the shell number. And as the size of the atom increases, it means the outermost electron which is present in the last shell, that will have the less attraction with the nucleus. जो आउटरमोस्ट इलेक्ट्रॉन होगा किसी भी शेल में, उसका न्यूक्लियस के साथ इंटरेक्शन कम होगा. अगर उसका न्यूक्लियस के साथ इंटरेक्शन कम हुआ, साइज अगर इंक्रीज हुआ एटम का, तो उसका इंटरेक्शन न्यूक्लियस के साथ विल गेट डिक्रीजेस. एंड एज द इंटरेक्शन ऑफ द इलेक्ट्रॉन विद द न्यूक्लियस गेट्स डिक्रीजेस, इट मीन्स वो इलेक्ट्रॉन न्यूक्लियस से बहुत लूज अमाउंट में बाउंड होगा. और अगर वो लूज अमाउंट में बाउंड होगा, सो वी विल रिक्वायर वेरी लेस एनर्जी टू रिमूव दैट इलेक्ट्रॉन फ्रॉम द एटम. सो दैट्स व्हाई आयनाइजेशन एंथैल्पी गेट्स डिक्रीजेस, बिकॉज द रिक्वायरमेंट ऑफ एनर्जी डिक्रीजेस एट दैट टाइम बाय द इंक्रीज ऑफ द साइज. सो टू रिमूव द outermost electron from the bigger atom, it becomes easier because the electrons are loosely bound with the nucleus at that time. So the value of ionization enthalpy gets decreases to remove an electron from an atom when the size of the atom gets increases. So the first factor is the size of the atom. Now the second factor is nuclear charge. Ionization enthalpy increases with increase in the nuclear charge. First of all, nuclear charge is, it is the attraction of the electrons with the nucleus. and higher is the attraction of the electrons with the nucleus, higher will be the nuclear charge. And as the nuclear charge is higher, the ionization enthalpy will get increases, because ionization enthalpy is the enthalpy or the energy which is required to remove the electron from the atom. और अगर इलेक्ट्रॉन ही न्यूक्लियस की साइड को अट्रैक्टेड होंगे किसी भी एटम में, तो उसको हमें ज़्यादा एनर्जी की रिक्वायरमेंट होगी उन इलेक्ट्रॉन्स को उस एटम से रिमूव करने के लिए. सो इट मीन्स अगर न्यूक्लियर चार्ज बढ़ता है, अगर फोर्स ऑफ अट्रैक्शन इलेक्ट्रॉन्स एंड न्यूक्लियस के बीच में इंक्रीज होता है, इट मीन्स न्यूक्लियर चार्ज इंक्रीजेस, सो आयनाइजेशन एंथैल्पी विल गेट्स इंक्रीजेस. And you can see also the force of attraction is directly proportional to the product of the charge on the nucleus and the electrons. Therefore, this increase in nuclear charge, it becomes more difficult to remove an electron and ionization enthalpy gets increases. क्योंकि अब इलेक्ट्रॉन ज़्यादा न्यूक्लियस के क्लोज बाउंडेड होंगे, तो अब हमें ज़्यादा अमाउंट में एनर्जी की रिक्वायरमेंट होगी इलेक्ट्रॉन को रिमूव करने के लिए किसी भी एटम से. तो एट दैट टाइम ionization enthalpy gets increases. Now the third factor is electronic configuration. For this, more stable the electronic configuration, the greater is the ionization enthalpy. Basically, stable electronic configuration, we get the stable electronic configuration when any of the orbital are half filled or the completely filled. अगर कोई भी ऑर्बिटल हमारे पास या तो हाफ फिल्ड हो या फिर वो completely filled हो, तभी हम उस कॉन्फ़िगरेशन को हम बोलते हैं द कॉन्फ़िगरेशन इज अ स्टेबल इलेक्ट्रॉनिक कॉन्फ़िगरेशन. और अगर कोई भी हाफ फिल्ड एंड कंप्लीटली फिल्ड ऑर्बिटल की कंडीशन है, सो इट मीन्स वो तो स्टेबल कॉन्फ़िगरेशन है. और अगर वो स्टेबल कॉन्फ़िगरेशन है तो हमें ज़्यादा अमाउंट में एनर्जी की रिक्वायरमेंट होगी उन हाफ फिल्ड एंड कंप्लीटली फिल्ड ऑर्बिटल से इलेक्ट्रॉन्स को रिमूव करने में. नाउ सपोज इन केस ऑफ p subshell there are 3 orbitals, and for half filled p orbital there will be 3p electrons. There will be 3 electrons in p subshell. So to remove these 3 electrons, because it is half filled, to remove these electrons from any of the atom, it is difficult to release because the high amount of energy is required because it is a stable configuration. Similarly, in case of completely filled p orbital, there should be 6 electron in p orbital. So to remove those 6 electrons, it is difficult. It requires much amount of energy. That's why stable or electronic configuration have the greater ionization enthalpy. Now come to the periodic trend of ionization enthalpy. First is variation along a period. In general, the ionization enthalpy increases with increase in atomic number in a period. When you move left to right in a period, we know that atomic number gets increases, and with increase in that atomic number, the ionization enthalpy also gets increases. Now, and this is because due to the increase in nuclear charge and decrease in atomic size. Because on moving left to right in a period, we know that nuclear charge increases, and we checked it in our previous video where we discussed about the atomic radius. So on moving left to right in a period, there is an increase in nuclear charge. It means there is an increase in attraction of electrons and the nucleus. So the nuclear charge gets increases, and as the nuclear charge increases, so we require much amount of energy to release electrons from the atom. So in general, ionization enthalpy along a period will get increases with increase in atomic number. However, some irregularities in the general trend have been observed here. There are some irregularities as well, and those irregularities have been observed which are due to the half filled and the completely filled configurations. जो हमें इन irregularities इस ट्रेंड में मिलती हैं, क्योंकि इन जनरल आयनाइजेशन एंथैल्पी इंक्रीज करती है, बट जो irregularities कुछ आती है आयनाइजेशन एंथैल्पी में, इट इज ड्यू टू द हाफ फिल्ड एंड द completely filled configuration which have the extra stability. As I already told you, half filled and completely filled orbitals have extra stability. So to remove electron from half filled and completely filled orbital, it is difficult. So whenever the case is there जहाँ पे हमारी आयनाइजेशन एंथैल्पी की वैल्यू या तो आयनाइजेशन एंथैल्पी की वैल्यू लो होना चाहिए बट वो हाई होगा, या हाई होना चाहिए वो लो होगा, इट इज डिपेंड्स ऑन द stable configuration, either half filled or completely filled. Now let's check this with an example, and the example of second period elements. So let's check the variation. Here are second period elements. As we know that ionization enthalpy in general increases when we are moving in a period. So here it is increasing, but there are some irregularities in the ionization enthalpies. Now let's check. Suppose we are moving from lithium to beryllium. So we can see here there is an increase in the ionization enthalpy because of increase in the atomic number. But here in this case there occur a difference in the ionization enthalpy, as boron should have high ionization enthalpy according to higher atomic number, but here beryllium has the higher ionization enthalpy than boron. Now the reason behind this, it is due to the stable electronic configuration of beryllium. Since we know that beryllium has 1:2:2 electronic configuration, which is stable as compared to the electronic configuration of boron 1:2:2p1. So it is easier to remove one electron of boron from the p orbital than to remove the electron of beryllium from 2s2 orbital, because in s orbital of beryllium there are 2 electrons are filled, and it is difficult to remove these 2 electrons from as compared to the 1 electron of boron from 2p orbital. So that's why beryllium has higher ionization enthalpy as compared to boron. Now if we move forward, and then after boron carbon is there, so carbon has higher ionization enthalpy than boron because of the increasing atomic number. Now after carbon it is nitrogen. Nitrogen also has the higher ionization enthalpy than carbon because of increasing atomic number and increasing nuclear charge as well. Now as we come to nitrogen to oxygen, there is slight decrease in the ionization enthalpy of oxygen, but it should be greater than nitrogen, but here is a decrease in the ionization enthalpy of oxygen. Now what's the reason behind this? Again the reason is due to the stable electronic configuration of nitrogen than oxygen, because we know that the outermost electronic configuration for nitrogen is 2s2 2p3, and here the p orbital is half filled, and we know that half filled orbitals are stable in nature, and due to this stability the more energy is required to remove electron from the half filled orbital of nitrogen as compared to oxygen. That's why nitrogen has higher ionization enthalpy than oxygen. And after oxygen, fluorine has higher ionization enthalpy according to increase in atomic number, and then neon will have higher ionization enthalpy due to the increase in atomic number. Now come to the next, variation in a group. So ionization enthalpy decreases on moving top to bottom in a group. When we move from top to bottom in a group, there is a decrease in ionization enthalpy, and again it is because of the increase in atomic size from top to bottom in a group. And as I already told you, whenever the atomic size will get increased, it means the attraction of the electrons with the nucleus will be less, and as the attraction of the electrons with the nucleus is less, it means the atomic size will be higher, and the atomic size is higher, it means outer electron will easily be removed on giving some energy. The outermost electron will easily be removed from the atom, so the value of ionization enthalpy will be less when we move from top to bottom in a group because of the increase in atomic size here. And for group first element, here we can see for group first element, so this will be the trend for group first element. This lithium will have the higher ionization enthalpy because of its smaller size. Then after lithium, sodium will have the lower ionization enthalpy because उससे इलेक्ट्रॉन को रिमूव करना will be easier. उसका जो outer most shell होगा वहाँ उसका holding capacity इलेक्ट्रॉन की न्यूक्लियस से कम होगी, तो वहाँ से इलेक्ट्रॉन को रिमूव करना easy होगा, तो ionization enthalpy decrease होगी लिथियम के कंपैरिजन में. Now when we move towards पोटेशियम, तो उसकी आयनाइजेशन एंथैल्पी और डिक्रीज करेगी. देन रुबीडियम की आयनाइजेशन एंथैल्पी विल आल्सो गेट डिक्रीज. देन सीजियम की कंडीशन में सीजियम विल हैव द लोएस्ट आयनाइजेशन एंथैल्पी अमंग ग्रुप फर्स्ट एलिमेंट. क्वेश्चन एंड आंसर टाइम. So question is, predict which atom is in each of the following pairs has the greatest first ionization enthalpy. And the questions are boron and carbon, and in between fluorine and neon, and in between nitrogen and oxygen. So the solution is, in between boron and carbon firstly, carbon will have the greater ionization enthalpy, as we know that as when we move left to right in a period, the value of ionization enthalpy increases due to increase in atomic number, and you can say due to increase in nuclear charge as well. So carbon is present at the right hand side of the boron, so carbon will have the higher, as well as it will have the higher atomic number than boron. So the ionization enthalpy of carbon is higher as compared to boron. In case of fluorine and neon, again neon will have the higher or the greater ionization enthalpy because of this reason, because when you move left to right in a period, neon is the rightmost element of the periodic table, and it is present at the right hand side of the fluorine. So it means neon will have the higher ionization enthalpy, as well as neon is a noble gas, and noble gases have the completely filled orbitals, and due to their completely filled orbitals, they require much amount of energy to release electron from their orbitals or from their shells. तो नियॉन का completely filled orbital होने की वजह से उसके पास एक स्टेबल इलेक्ट्रॉनिक कॉन्फ़िगरेशन है, जिसकी वजह से भी हमें ज़्यादा अमाउंट में एनर्जी की रिक्वायरमेंट होगी नियॉन से इलेक्ट्रॉन को रिमूव करने में एज कंपेयर टू फ्लोरीन. Now the next is nitrogen and oxygen. Now here, in between nitrogen and oxygen, general trend of ionization enthalpy will not follow. Now here it is an exceptional case. Nitrogen will have the greater ionization enthalpy because of the stable electronic configuration of nitrogen, because the electronic configuration of nitrogen is 2s2 2p3, in which p orbital is half filled, and we know that half filled orbitals are stable, and to remove electron from any of the stable configuration it is difficult. We require more energy to remove electron from any of the stable configuration. So nitrogen will have greater ionization enthalpy as compared to oxygen. Now I have some practice questions for you. Now do these questions. Which of the following pairs of elements will have the lowest first ionization enthalpy, and you have to explain as well the reason. The questions are in between chlorine and sulfur, in between potassium and argon, and in between chlorine and fluorine. Second is, from each set choose the atom which has the largest ionization enthalpy, and these are three sets in which you have to choose the atom. From set 1 you have to choose one atom which has the largest energy, similarly from B and similarly from C as well. Question third, would you explain the fact that the first ionization enthalpy of sodium is lower than that of magnesium, but its second ionization enthalpy is higher than that of magnesium? So these are three questions. Do these questions, and we will meet in our next video with our next topic. Thank you. Keep watching.